visualize the actual graph in your mind. So we have the tangent. Let's just talk about regular tangent. What's tangent look like? Yeah, like a cube graph, this guy here. So this is tangent. If I take its inverse, now we have the inverse. So if I want the domain of the inverse, negative infinity, positive infinity. So domain of, here we go. The tangent is negative infinity to positive infinity. And that's because the range of the regular tangent would go from negative infinity to positive infinity. So the range of the function becomes the domain of the inverse. So they flip. The second one says the domain of cosine, inverse cosine. So think of the regular cosine graph. The regular cosine graph starts high, ends high, but here would be like the regular cosine graph, the range. That becomes the domain of the inverse. So what two numbers does cosine go between, Kevin? Yeah, so the lowest is -1, the highest is +1. So that becomes the domain of its inverse. So -1 to 1. I'm going to skip down to number 3 just so we do all the domain questions together. I'm not sure why I typed them up differently. Who knows? I was probably talking. Sometimes when you're talking and you're trying to do something, it doesn't go so well. If you're trying to do something with your phone, Kevin, and then do your homework at the same time, Kevin. So if you go down to number 4, what's the domain of the sine, the inverse sine? Same thing as cosine. Because sine and cosine go between -1 and 1. On the unit circle, sine and cosine go between -1 and 1. There aren't any other values on the unit circle beyond those. So the domain for sine and cosine is exactly the same because their graphs, the regular graph, goes between -1 and 1, those hills and valleys. So yesterday when we talked about these 3, these all were the restrictions on x. The range for these graphs are really the restrictions on the angles. So when you think of the range for the inverse, it really is an angle value because that was the domain for the regular function. So now it's really the range, which is the angle values. So what angles would work for the inverse sine, Odette? Yeah, so -π/2 to π/2. And that is because anything after that, it starts curving back up or it starts curving down and it doesn't pass the horizontal line test. So that's why it has to stop at those 2 points. For number 6, we have the range of the inverse cosine, Jacob. There we go. So cosine is 0 to pi. So after you look at from 0 to pi, which is actually what I have graphed here, from 0 to pi, then after that, it doesn't pass the horizontal line test. So I just have that piece of the curve from 0 to pi, Jacob. Okay, so then the last one, number 6, for tangent would be? And it gets parentheses because there's asymptotes, right? So it has horizontal asymptotes running on the top and the bottom of the graph because they were vertical. Now they flip to be horizontal. So there are 3 places that you can find this information. When we graphed it, after we looked at the graph, underneath we went through the same question. So each graph, we said what's the domain and the range of the inverse. We then said what's the domain and the range of the regular function. And then yesterday, on page 58, we went through these restrictions. Again, we talked about restricting x. We talked about restricting the angle. And then you have it right now. That's something, please look over, because if you give an answer that isn't within these angles, then it's an angle that doesn't exist for the inverse. So you kind of need to know where does it exist, where is it defined in order to give a valid angle answer. Your test tomorrow is 40 points. The first page are inverse functions, which is roughly 20 points. The next 2 pages are word problems. So it is half and half, except you're going to have more questions on inverse functions because they're not worth as much. There's not as much thought process going into it. The word problems are a little more involved. You got to draw a diagram correctly. You have to figure out a couple of different pieces of the triangle. And we're going to go through some of those together. Questions? So then if you look at that word problem, or I'm sorry, the review worksheet. Number 3, so looking at number 3, as the arctangent of -3, and the first thing that you would do is rewrite this as an equation. That would be step 1. Draw yourself maybe a little diagram. We just said tangent has to be between -pi/2 and pi/2. And then you're trying to think of an ordered pair that would give you a -3. There isn't one on the unit circle because any of the ordered pairs in the unit circle don't give you a whole number or an integer of -3. Maybe a -1 or a 0, but never just a -3. So this one you had to use a calculator for. It's the only one that you needed to use a calculator. So when you looked at the answer key and you saw a decimal, that's because the only way to get the decimal or angle is by using a calculator in radians. So that is a radian angle that was given to you. The other ones you didn't need to use a calculator for.
So how do we know? No, never mind.
Okay. Are there questions from 1 through 6 that you wanted to go through? Allie?
Did you do 4?
Yeah. So looking at number 4, if we start in the middle, I'm going to just rewrite this first. So I usually take the equation, whatever it says arctan, arc cosine, arc sine, I try and just rewrite it first. So in this case, arctangent -2/3. And then I draw myself a little xy axis. Tangent doesn't exist over here, so I kind of wipe that out. And then I go to the unit circle and I say, is there anywhere on the unit circle that I can get a -2/3? No, not for tangent. But I could draw a triangle to help solve the answer. So if I was drawing a triangle, would I draw the triangle, Maggie, in the first or the fourth quadrant for tangent if it's negative? The fourth. So draw myself a little triangle. And Maggie, labeling the triangle with tangent are what 2 sides?
Opposite and adjacent.
Yeah, opposite, -2, adjacent, 3. And then to get the hypotenuse, wonderful Pythagorean theorem. So 3 squared is 9, 2 squared is 4, gives us the square root of 13. So you draw the diagram with the middle. This is kind of like a composite function. So you do the middle part and then you evaluate the outside. So the outside says cosine. Mariella, what 2 sides of the triangle are cosine?
Adjacent and the hypotenuse.
Yeah, so if we're looking at the adjacent, Mariella, that would be,
3 over the square root of 13.
is it 15? 9, 13? And then how do you rationalize that?
You'll multiply the square root of 13.
Yeah.
That would equal 3 times the square root of 13 over 13.
There you go. So draw a diagram from the middle, evaluate with the outside. So you could actually have one diagram with the middle being the same, and we could have anything outside there. So you could have tangent outside, we could have sine outside. We could find like 6 different functions that would be on the outside with one diagram. Questions? So let's look at letter yet. How about number 7? So we have a boat that is d feet from the shore. And a person is standing on a dock that is 25 feet above the ground, which actually that's a pretty high dock. I mean, it must be a really big ship coming into the dock, not like a little boat. Then the little boat, you wouldn't be able to get onto the dock. So, this is 25 feet. And the ship is D. We don't really know how far, but it could change, come closer as it's coming in. But that distance is D. The most important part of this diagram is where to draw the angle of depression, which throughout the day I've seen the angle of depression drawn incorrectly. I think that's the angle that gets drawn incorrectly most often. So how do you draw an angle of depression? The angle of depression of the boat from the dock is theta. How do you draw an angle of depression, Maggie?
You have to draw a horizontal line at the top.
Yeah, so the angle of depression is from the horizontal line and the line of sight. So draw your horizontal line and then make a diagonal line that would be the line of sight. Technically from the person's feet, not from his eyes, but we're going with the information we have. So the angle of depression is this angle right here, not that. That angle is the bearing. The two together are complementary, but they're opposite angles. So the angle of elevation and depression go from the horizontal. The bearing goes from the vertical. So if I have a diagram drawn, and this is a horizontal, the distance that the person is above the water on the dock, horizontally going over is the same distance if I could just keep walking in the air, going over to be above the boat. If the distance that they are away from the bottom of the dock, then it would be the same as the distance from in the air. So if you look at the angle, you have opposite over adjacent, so that's tangent. So that's how I would set up my initial problem, but it says write theta as a function of D. This means that that's what you want to solve for. So I don't want to leave it as tangent of theta, you just need to have theta by itself. How would you plug that into the calculator? So if I said D was 37, and I had the tangent of theta equals 25 over 37, how would you put that in the calculator, Quinn? Yeah, so you would do the inverse of tan, and then if I was plugging in the calculator, I would do 25 over 37, or whatever that happens to be. Well, in this case, it's just 25 over D. That's how you get the angle by itself, by using the inverse function. You can keep it as tan negative 1, you could write it as arctan. It's up to you. Both of them mean the same exact thing. So 25 over D.
If you write arctan, do you need the parentheses?
No, you don't. And technically you don't really need parentheses there. Questions on that? Number 8. Is that one okay? Yeah.
Okay, it could be totally missing something, but how do you know which side A is on? Because I did it as sine first and then got the wrong answer, so then I redid it as cosine and got the wrong answer.
Okay, so that part doesn't matter. So I don't know how you have your triangle drawn. You can draw both ways. Yep. So it says C is the right angle. The way you label A and B, it does not matter. So if you like B on the top and C over here on the A over there, that's fine. The part that matters is where you position the side. So if you know that angle B is 6.84, it doesn't matter if it's at the top or if it's at the bottom. But side B has to be opposite angle B. That's the part that matters. So then side A has to be opposite angle A, which this is 21.3.
Yeah, I did it as opposite angle first, and then I didn't realize.
So if you don't have the side and the angle pairing together, then you're good. Yeah. So that's the key thing. Your side and angle must pair together. Little c across from uppercase C. Allie.
Why is that? That it's not this. I was just thinking that the angle and the side were connected to
So by definition of a triangle, an angle and the side across from it are the ones that ratio, like when we're thinking about proportions and ratios from geometry. Those are the ones that would get proportioned or ratioed together. So side and matching angle. The matching angle is across, diagonal from it, not attached. Questions on that? I think number 10, there were a lot of questions on, so if you want to look at number 10. So number 10, we have a pilot in an airplane flying at an elevation of 5,000 feet. Anybody know? Is that high for a plane, 5,000 feet? No. How high does a plane usually fly if they reach their cruising altitude? 30,000, 35,000, somewhere in between there. So a plane, like 5,000 feet seems high to us. It's a little less than a mile. But that would be like one of the planes that we see flying over us very frequently. They might be a little less than 5,000 feet in the air, but like that isn't very high. So 30,000 feet in the air is where a typical plane would fly. So this is kind of cruising lower. So here's our 5,000 feet. That would be the height. It sees two towers. The hardest part is to think when you see those two towers that, like, I have my tower kind of drawn underneath. So we don't know how tall the tower is. So you have to think that, like, the angle goes to, like, the tip of the tower, or that it goes, like, to the bottom of the ground, to, like, the bottom of the tower. But I don't know the height of the tower, so I can't really use that as information. So that 5,000 feet has to really go from, like, either the top of the tower up to the plane, or you're thinking like you're going to the bottom of the tower. So we have an angle of elevation or depression to the closer tower is 30 feet, 30 degrees, not feet. So here's your horizontal, as if the plane were continuing to fly forward in a horizontal format. Here's my line of sight to the tower. So I just put a little tick mark there to represent the tower. 30 degrees is this angle right here. So there's two ways you could approach this problem. You could use this triangle here to get the distance from the plane to the tower. Or you could make yourself another triangle up above here, but somehow you have to figure out the distance that tower 1 is from the plane, because we know the distance between them is 300 feet. So I need to get that horizontal distance. You can do it two ways. So the angle here is 60 if the other angle is 30. But you need to find one of those two distances to add the 300 feet to it. Allie, question?
That was my question.
Okay. So either way you work through it, it's up to you. But if you're over here, it's still 5,000. So opposite adjacent would be tangent. Or if I use 60, it's still opposite and adjacent. But your goal then is to find out this angle. That's the goal. So you need to get the whole distance in order to get the angle, but you're using tangent to get there. So angle of elevation is that horizontal. Remember that for tomorrow. Angle of depression, angle of elevation, horizontal. Emma?
So in a problem like this, when it says angle of depression, it's from the horizontal on top, and then angle of elevation is
Would be, right. So if you were standing on top of the building looking up to the plane, it would say the angle of elevation.
so you wouldn't have to draw like the other one.
Other questions on that one? So the last one is definitely a challenging problem. And somebody asked, would you have one exactly like this on the test? And I said no. It makes a great homework problem because it makes you think. If there was one like this on the test, you probably wouldn't have enough time. Because you really have to like think outside the box. If we did enough of them like this, then yes. So if we did 5 more problems like similar to this, where you're trying to draw the triangle outside of the given information, then it would probably be something that we could talk about. Yeah.
Okay, so when I was doing this, I was looking at a picture and I didn't know how to read it, and I was confused on. So you see how the little triangle at the bottom there?
Yeah.
I was confused on which angle was the wouldn't that be 65 degrees too?
Mhm.
And I was like, so the next one there is 25 degrees.
Not necessarily, because this isn't a right angle here.
Okay. I think that's what I was thinking.
Yeah. So just kind of reading through the directions, just to kind of get you to see how, as Kevin said, kind of talking about how I created. So starting with A, traveling to B, they give you this angle from north 48 degrees to the east. So that was given. And then the other information given was from B, traveling to C, 810 miles, and that angle was south 65 degrees to the east. The other angles that I labeled, alternate interior angles are the same, they're congruent. So this is 48, that one's 48. Kevin said this is 65, so the one down there is 65. The reason I have all these extra triangles drawn is because this diagram here is in a right angle. You have a 65-degree angle, a 48-degree angle, that's an obtuse angle. In order to solve a triangle, it must be a right triangle. In chapter 6, we'll solve this same problem without using right triangles. But it's easier. So what I chose to do was I made pretty much two parallel lines on the top and the bottom of the triangle. So here is the horizontal, and then I took this XY axis and I just extended it, and it got a little slanted. It was supposed to be as horizontal as I could get it. I should have used a ruler, but I made the same horizontal down here, and then I made an XY axis, because if I have an XY axis, it's a 90-degree angle. So the 90-degree angle is down here with this little triangle underneath. And that little triangle underneath is important because it also matches with the triangle above. They share the same side. And that's what you're trying to find. You're trying to find A to C. That's the goal. So I needed to figure out a way that I could find that distance. And the only way that I could find that distance was to make a triangle underneath it that would be a right triangle. So if this is 65, up here is 25. I have D1 and D2 because if I add that together, it's the whole bottom of the triangle. And I also labeled D3 and D4 because if I subtracted them, that would give me the little height here of the triangle. So if I looked at this side and I wanted to find D4, how could I find D4? Emma?
We took the side and 25.
Yeah, so here's 25. She said sine. And Emma, that's equal to?
D4 divided by 810.
Right. So that gives me then from this top horizontal to where the original triangle ends. It gives me like that one side. And if I did the same thing with D2, Emma, you would use?
Sine of 65.
If I wanted to get this up here, trying using this same thing.
Cosine of
Yeah.
25.
That's all right, you're good. What you said was not wrong. So then I could use the cosine of 25. So that gives me these two sides of the triangle. I would do the same thing on the other two sides. So then if you add the two pieces on the top, that gives you the horizontal on the bottom. If you subtract the two vertical pieces, that gives me this little piece down here so that I can use Pythagorean theorem. I think this ends up being 93. So if I know 12, 17, 93, then I can find that distance. But like it is a hard problem. You have to think outside the triangle. It's like nothing in the triangle is a right triangle. So I think instead of outside the box, outside the triangle. After you have those sides, your goal is to find the bearing, and you need this little angle inside that triangle to get the bearing, because the bearing goes from north and it moves east. And apparently I had a really hard time typing an answer key because I had 25 divided by 5, which was supposed to be divided by D, and then this bearing is supposed to be north to east. You can't move north to south. Like, it doesn't work like that. Don't know. I did so good. Then the answer key just, who knows. But that little angle is 4.6, I think. So what other questions can I answer, Kevin?
So, was it okay that I found the little angle right there? I think I used that to find the distance from A to C.
Yeah,
About 12,
yeah.
18. Is that something like
Oh yeah,
Is that okay?
yeah. That would work too, yes. So you found the angle and then yes, that would work. Yes. Yes. Your answer is just gonna be slightly off because you're using the angle instead
Yeah, I
of
figured
yeah.
since I kept rounding.
Yes, yep, but yes, that is fine. Maggie.
For these polls, do you need to round because
I will say specifically tomorrow to round to 1 or 2 decimal places for all of the problems. I
This one
specifically.
wasn't rounded.
Yeah.
Or
So-
it was rounded.
What kind of questions about the inverse of Like,
Um,
is it just like you want to use it?
Yep, similar to those. So she asked a good question. For homework tonight, I have a couple extra problems up here as well. But on the board, on your assignment sheet, for an optional review, and this is totally optional, I'm not collecting it, I'm not grading it, but if you feel more confident practicing some extra problems, in the book on page 322, we did 5 to 13 part A, but there was a part B. So any of those questions are good ones to look at. And then 53 to 67 off. Those would be extra inverse questions. Up here, these are 4 word problems that I think are pretty good word problems that if you wanted to look at, it's just number 40 is a great problem, but of course it's an even problem. But number 40 would be a good one to look at. A great problem, but it's even. Even answers are in the back of it. And then the midterm review packet, 51 to 75, that's for Friday. So just to keep you kind of on track, I'll remind you tomorrow, but Friday is a question answer day for midterm. So as you're working through, put answer questions at the top of the midterm so that you know what you want to ask on Friday.